Hey everyone, let's work through some examples from Chapter 8, Section 8, solving radical equations and inequalities. So on these first ones, we're going to solve each equation. So we have 5 plus the square root of x plus 1 equals 16. So to solve for x, I need to get that x by itself. So first of all, I'm going to subtract 5 from both sides. So I have the square root of x plus 1 equals 11. To get rid of the square root, the index is 2 even though we don't have it written there. But I will square both sides because the square root and the square will cancel out. So I'm left with x plus 1 equals 121. And then to get x by itself, we'll subtract 1 from both sides. So we get x equals 120. By the way, whenever we are solving, it's really important to go back and check your answer. So take that 120, if we plug that in for x. 120 plus 1 is 121. The square root of 121 is 11, and 11 plus 5 is 16, so that does work. But it's a good habit to get into because in some of these later examples, you'll see that sometimes we end up with extra solutions that do not work. Okay, now for the next one. We have 7 times the cube root of 5x minus 7 equals 84. So again, to get that x by itself, I'll start out by dividing both sides by 7. So now I have the cube root of 5x minus 7 equals 12. Now I have to think, what cancels out with the cube root? Well, if I raise this to the power of 3, if I cube both sides, the cube root and the cube cancel out, so I'm left with 5x minus 7 equals 12 cubed is 1728. Now I just solve, and it's really easy. Also, add 7, so I'll have 5x equals 1735. And then divide by 5 and I get x equals 347. Okay, now let's solve these. You'll notice that this time we have radicals on both sides of the equation, and that's okay. So I have the square root of 7x plus 2 equal to 3 times the square root of 3x minus 2. I don't want to divide both sides by 3, then I would have multiplying by a third, so it doesn't do any difference to move the 3 from one side to the other. But I can take both sides and square the entire side on each side. So the square root of 7x plus 2 squared is just 7x plus 2 equals, now this 2, tongue-tied. Okay, 3 times the square root of 3x minus 2. When I square that whole thing, I have to distribute that squared to both parts. So 3 squared is 9. And the square root of 3x minus 2 squared is 3x minus 2. So be really careful with that kind of thing right there, because now I have a 9 to distribute. So I have 7x plus 2 equals 27x minus 18. Now I can solve for x. So if I subtract 7x from both sides, I'll get a 20x over here. And if I add 18 to both sides, I'll get a 20 over here. Then divide both sides by 1. So I'll get x equals 1. Again, it's always good to check that answer. So we had the square root of 7 times 1 plus 2 equals 3 times the square root of 3 times 1 minus 2. So that's the square root of 9, which equals 3. And here we have 3 times the square root of 3 minus 2 is 1, so that equals 3 as well. It checks out. So x equals 1 is the answer. On this next one, we have a cube root of x plus 7 equals 2 times the cube root of x minus 1. It's really similar here, except instead of having a square root to square, we have a cube root that we'll need to cube. So I've got the cube root of x plus 6 equals 2 times the cube root of x minus 1. And to cancel out that cube root, I'll cube the entire side on the left and the right. So on this side, I'll have x plus 6. Over here, distribute that cubed. So I have 2 cubed, which is 8, and the cube root of x minus 1 cubed is x minus 1. Make sure to leave that in parentheses so you can remember to distribute the 8. So we have x plus 6 equals 8x minus 8. Now solve. Subtract x from both sides and we get a 7x. And add 8 to both sides and we get 14. Divide both sides by 2, you get x equals 2. Again, let's check that answer. The cube root of 2 plus 6, that's the cube root of 8, which is 2. On the right-hand side, we have 2 times the cube root of 2 minus 1. Sorry, if you just heard me say hi, it's because someone walked in the room. Okay, back to where we were. Okay, so we have 2 times the cube root of 2 minus 1, which is 1. So 2 equals 2. That checks out. X equals 2 is the answer. Okay, so raising each side of an equation to an even power may introduce extraneous solutions. So let's check out this one. We have the square root of negative 3x plus 33 equals 5 minus x. So if I want to square both sides, then on the left-hand side, I'll have negative 3x plus 33. The square root and the square cancel out. And over here, I'll have 25 minus 10x plus x squared. If I move everything over to one side of the equal sign, if I add 3x and subtract 33, then I'll get 0 equals, and I'm going to rearrange it, x squared minus 7x minus 8. That will factor into x minus 8 times x plus 1. So I can set each of these things equal to 0 and solve for x. So I get 8 and negative 1. Nothing seems too suspicious about that just yet, but let's check each of these answers. If I check x equals 8, I'll have the square root of negative 3 times 8 plus 33 equals 5 minus 8. So we need to check, is this thing really equal? So I have the square root of negative 24 plus 33 equal to negative 3. This is equal to 9. So here I actually get 3 is equal to negative 3. That's similar, but not quite. That's not what we're looking for. So if x equals negative 1, again, going to plug it in. So I have negative 3 times negative 1 plus 33 equals 5 minus our negative 1. So here I'll get the square root of 36 equals, that adds up to 6. So here I get 6 equals 6. So notice that is exactly the same. That's what we're looking for. The 8 is the extraneous solution. The negative 1 is our solution for this problem. Okay, let's solve these. Here you notice we're looking at rational exponents. And this really works the same way as radical expressions. So if we have 5x plus 7 raised to the 1/3 equals 3. You can think about this as the cube root of 5x plus 7, or we can still just consider raising both sides to the same power. So what do I multiply 1/3 by to just make it cancel out to 1? Well, 1/3 times 3 equals 1. So if I raise each side to an exponent of 3, I'll get 5x plus 7 equals 3 cubed, which is 27. I can now subtract 7, divide by 5, and I get x equals 4. Let's check that answer. So we have 5 times 4 plus 7 raised to the 1/3, is that equal to 3? So we have 27 to the 1/3, and 27 to the 1/3 power, the cube root of 27 is 3. It all checks out. 4 is the answer. Similarly, let's look at this next one. So we've got 2x equals 4x plus 8 raised to the 1/2. So now, instead of raising it to the 3rd power on both sides, we need to cancel out that 1/2. What multiplied by 1/2 will just give me 1? Well, 1/2 times 2 will give me 1. So if I square both sides, remember to distribute this squared here. 2 squared is 4. And be careful because I really feel like that's a place that you could easily mess up. And then I get x squared equals 4x plus 8. I'm going to move this all over to one side of the equal sign. So I have 4x squared minus 4x minus 8 equals 0. Let's try factoring this. I'm going to take out the GCF of 4. So now I have x squared minus x minus 2 equal to 0. And that factors nicely. I've got x minus 2 times x plus 1. So I'll set each of these factors equal to 0 and solve for x, and I'll get x equals 2 and x equals negative 1. Again, let's check these answers. So 2 times 2 equals 4 times 2 plus 8 raised to the 1/2. So there I'll have 4 equals, that's 8, so 8 plus 8 is 16, and 16 to the 1/2, or the square root of 16 is 4. That one checks out, so we know that 2 is an answer. But let's check the -1. So we have 2 times -1 is -2 equals 4 times -1 is -4, then plus 8 raised to the 1/2. So I have -2 equals 4 to the 1/2, or the square root of 4. So -2 equals 2? That's not true. It's similar, but the signs are not the same. That one does not check out. So x equals 2 is our only answer. A radical inequality is an inequality that contains a variable within a radical. You can solve radical inequalities by graphing or using algebra. So let's solve this square root of 2x minus 6 plus 3 less than or equal to 9. So I'm just going to rewrite that over here. So I have 2x minus 6 plus 3 less than or equal to 9. Okay, I'm going to start out by subtracting 3 from both sides. So I have the square root of 2x minus 6 less than or equal to 6. Now I can square both sides to cancel out that square root sign. So I now have 2x minus 6 is less than or equal to 36. Add 6, I get 2x is less than or equal to 42. So when I divide by 2, x is less than or equal to 21. But we're not done here. There's something else that we have to consider. And that is that this number right here, because this is a square root, we cannot have this square root of a negative number, so we need to make sure that 2x minus 6 stays greater than or equal to 0. So that way we don't have any imaginary numbers involved. So I'll add 6 to both sides and divide by 3. So I have two parts to this. So I've got 3 is less than or equal to x. It's still opening the same direction, which is less than or equal to 21. And that is the set of solutions for this inequality. Okay, but let's check out this one. Here we have the cube root of x plus 2 is greater than or equal to 1. So here I have the cube root, I'm just going to rewrite it, x plus 2 is greater than or equal to 1. To cancel out that cube root, I'll cube both sides. So I get x plus 2 is greater than or equal to 1. So then I'll subtract 2 and I get x is greater than or equal to negative 1. So here, on the previous example, we had to check the radicand to make sure it stayed greater than 0. But actually on this one we don't, because we can take the cube root of a negative number and there won't be any conflicts whatsoever. So we can take the cube root of a negative number, it can be positive or negative, because the cube root of negative 8 can be both positive 2 and negative 2. So our answer here is just the x value is greater than or equal to negative 1. Okay, and here we have 3 examples not in your book, but these are important because maybe you'll see something like this again. So if we have x to the 4/3 equals 256, and I'm trying to solve for x, what do I multiply this exponent by so that it cancels out? So if I have x to the 4/3 equals 256, 4/3 times what equals 1? Well, if I just multiply by this reciprocal here, 3/4, and I do that to both sides, don't forget that, the exponents will cancel, so we just have x to the first power equals, and if you don't like thinking about it in a form of a rational exponent, rewrite it so that you have the 4th root of 256 cubed. The 4th root of 256 is 4, and 4 cubed is 64 And that's my answer. Let's look at this next one. We have 3x to the 2/5, and I'm going to go ahead and add that 12 to the other side. Let's also divide by 3. So now we have x to the 2/5 equals 4. 2/5 times what gives me 1? Well, if I just take the reciprocal here, 5/2, raise that to the power of both sides. On that power of both sides, those exponents cancel. So we're left with x equals, this is the same thing as the square root of 4 raised to the 5th power. The square root of 4 is 2, so 2 raised to the 5th power is 32. And one more, we have x to the 3/2 equals -8. So I'm trying to get rid of that 3/2 exponent to solve for x. So again, I'll multiply that by its reciprocal on both sides for the exponents. Oops. It's 2/3. This over here to the 2/3. That cancels and we're left with x. And then here we'll have the cube root of -8 squared. So x equals, the cube root of -8 is -2. -2 squared is 4. And that's it. I hope that made sense. And if you have any questions, let me know. I will see you later. Bye.